Using the James Webb Space Telescope, astronomers have revealed new atmospheric details about WASP 107b, an exoplanet known as the popcorn planet due to its puffed-up nature. Recent findings show a surprising east-west asymmetry in its atmosphere, a characteristic previously unseen, offering fresh insights into the dynamic atmospheric conditions of such unique celestial bodies. The fascinating popcorn planet is back in the spotlight. Using NASA's James Webb Space Telescope JWST, a team of international astronomers has discovered new atmospheric details on WASP 107b, an exoplanet with a puffed-up atmosphere due to tidal heating. Previously described as an extremely low-density popcorn planet by researchers, WASP 107b has once again proven to be an intriguing subject, revealing even more surprising characteristics about its inflated and dynamic atmosphere. WASP 107b, a gas giant about the size of Jupiter, but with just 1/10 of its mass, has long baffled astronomers with its puffy, inflated state. Now, JWST's advanced observations have provided an even closer look, revealing an unexpected east-west asymmetry in its atmosphere, marking one of the first times such details have been observed in an exoplanet. Previous findings showed that WASP 107b is extraordinarily puffed up, almost as if the planet had popped like a kernel of popcorn under its own heat. With JWST, we are getting a clearer picture of what's happening in its atmosphere in 3 dimensions, and it turns out there's even more to munch on. The study was published in the journal Nature Astronomy. Earlier in 2024, the previous study led by ASU researchers revealed that WASP 107b had a significantly hotter interior and a more massive core than previously hypothesized thanks to the broadband spectrum, showing simultaneous detections of carbon, oxygen, nitrogen, and sulfur-bearing molecules. Now, the reanalysis of JWST observations uncover an east-west atmospheric asymmetry. This feature suggests differences in the properties between the two sides of the exoplanet. The source of this asymmetry is intriguing. While these initial analyses suggest that the asymmetries may be due to one limb of the planet being more cloudy than the other, this could also be linked to how heat is transported across the planet's atmosphere. WASP 107b is tidally locked to its star, meaning one side always faces the star, basking in constant daylight, while the other side remains in perpetual darkness. This condition, combined with the planet's low gravity and inflated state, makes WASP 107b an ideal candidate for studying the unique processes at work in exoplanetary atmospheres. To study the planet's atmosphere, researchers use the technique called transmission spectroscopy, which involves analyzing the starlight that filters through the exoplanet's atmosphere as it passes in front of its star. The high sensitivity of JWST allowed the team to isolate and examine the signals from the eastern and western edges of the atmosphere separately, something never before achieved with this level of detail. The high precision of JWST's instruments is like having a magnifying glass for planets. We can now look at specific processes happening on each side of WASP 107b's atmosphere, giving us valuable insights into how climate works in these extreme conditions. WASP 107b's atmosphere, which reaches temperatures around 890 degrees Fahrenheit, sits in an intermediate range between the planets in our solar system and the hottest exoplanets known. This makes it an important target for understanding the diverse climates and atmospheric dynamics of exoplanets. The researchers now plan to conduct additional observations to delve deeper into what drives this atmospheric asymmetry. These ongoing studies will help astronomers piece together the puzzle of how such inflated exoplanets maintain their structure and how heat, winds, and atmospheric chemistry interact to create the unique conditions observed on WASP 107b. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.